first we will go through the pre-quiz, and then we will look into boosting and bagging part that we left yesterday, and then you can ask your questions regarding assignments. So in pre-quiz, the first question was minimum or maximum of a function. We set a gradient to 0 because at the extrema of a function it is like the gradient of function is always 0. So first one is the correct one. Second, the mode is the number that is the most frequently occurring number. So 14 and 16 both would be the answer. So this has a bimodal data. Decision tree can be used for classification tasks, true, but it can be used for regression as well. But yeah, this statement is true. Overfitting causes poor generalization of behavior. This we we are discussing this from the first class that overfitting leads to poor generalization, and underfitting leads to like uh, too much of generalization. Which of the following is true about random forest and gradient boosting? So both are the assemble learning method, and both can be used for classification and regression task. So first and fourth option. In gradient boosting, it is important for learning rate to get optimum output. So basically, we want our learning rate to be as low as possible, but we should also take care of the computational power that we have in our system. So yeah, we want it to be low, but it should not be very low because it would be highly computational expensive, and our system might get crash. This is just a simple machine learning definition. Range. So range is basically highest minus lowest value. So I guess 350 minus 280, and the sum of percent frequency of all the classes will always be equal to 100. This is like same as pie chart. So now if anyone have question, please ask.
Yes.
Yes.
Yeah, so I had a question. The first question itself.
Okay.
So the function might not be differentiable at the maximum, right? So then it won't be zero. The gradient won't be zero. For example, let the function be e to the power minus x for the positive side and 0 for the negative side. Then the maxima is at 0, but the gradient won't be 0 at 0.
Uh, y- so yeah, those are the exceptional case. Like yeah,
I mean, the things that we consider during this ML, MLE, the MLE graphs that we draw aren't always the maximum likelihood estimation graphs, aren't always the maximum extremes are not always found using the gradient, putting gradient to 0, right? There are some cases where you just have to look at the graph and find it.
yeah. So for those cases, you can't put gradient to 0 because those are not differentiable at that point. Yeah, it's right.
Uh, so which is why I did C, both A and B, so because it depends on the problem, kind of.
Yeah, yeah. Like uh, okay, we can think like that way. Any other question? Yes,
I put down my hand. Thanks. That's it.
Ram.
Yeah. What do you mean by gradient boosting? Which algorithm corresponds to that?
Though that boosting part that we saw
Yesterday,
yesterday.
that's
Uh,
gradient boosting.
yeah, I guess this one.
Okay.
So we saw about ADA boost, gradient boosting, stochastic gradient boosting.
Okay.
Any other question? Okay, so now we will switch to bagging and boosting part. like their implementation. So as we saw, like in bagging, we have both of them are the ensemble learning model, and here the models are in case of bagging models are trained independently, and the prediction of one model will not affect the training of another model. So first we will implement bagging technique, then we will implement random forest, and at the last we will implement boosting technique. So here I have imported bagging classifier, decision tree. These two are a function accuracy score to measure the accuracy metrics, and this is just a function from models selection library. And seed one is just a variable to ensure the reproducibility of results. Again, we are using cancer data. So these two are for separating out the input and output of a model. Y is the label for the model. Then we will split the data on 70 is to 30 ratio, and random state equals seed, where seed is we have defined at 1. Now we instantiate decision tree classifier because target variable is binary, diagnosis 1 or 0. And here are the different hyperparameter value. You can tune it later if you want. And then we will pass this model, since bagging uses different tree model, right? So we will pass this model into this function bagging classifier with the base estimator as dt, where dt is defined as here, and n estimator 300, basically 300 different models, and each model will train as we saw yesterday in case of bagging. And then we will fit this model, this bagging model, to extend y train. We will predict here, and this is how we will get the accuracy in case of bagging. Yeah, so if anyone have question, Kasina.
Yes, sir. So in the bagging classifier, I guess we can put different models also, right? I mean, like one as a tree and the other as a cane and the other as a
That would
logistic.
be assemble learning, right? That
Okay.
we did earlier. Here
The
we did
voting classifier, the voting classifier
voting
one,
classifier. Yeah.
yeah, which
Okay.
we did. That was
Yeah.
a
Sorry.
means cluster of all the models.
Yeah. Okay. Sorry. Yeah.
Yes.
So what I wanted to ask was, is there a difference between this bagging classifier with the decision tree as its base estimator and a random forest?
So here we are not subsampling the training data set, right?
Oh, right, right, right. Thank you, thank you.
And random forest also use that sampling of features while training individual models.
Yes, yes, yes.
So
Thank
that
you.
is the
Got it.
main.
So which one would be a more preferable method? I guess random forest, right?
Yeah, because it introduced some generalization, but there is not a clear answer which one to use.
Okay, okay. Thank you.
Yes, are you done?
So we have one question, Rishabh,
Okay.
that what does n underscore job mean in bagging? We have used this, na, n underscore job, where it
Here.
got. Yes. So yeah. So means basically we are specifying the number of cores which should be used. If you are using -1, it means that all the cores should be utilized. Okay. And since the Google Colab is running on cloud, means it is using the resources of Google Cloud, so we are not bothered about our own machine. Okay, so that's why we can use all the CPU cores. You can also have n jobs equal to 10, just to use 10 cores at that point of time. There is one more question. What does stratify equals to y means? So yeah, so here you can see that means when the data set is imbalanced actually. then in that case we put this parameter. And what it does basically, it is simply trying to maintain the ratio while splitting. Okay, like suppose we are having 60% positive and 40% negative cases, so while splitting it will again maintain the same ratio. So that was the idea of stratify. What happens if after hyperparameter tuning the training score is 1? So training score is 1, so that means again, so you have to check it on your validation data, how it, whether the results are repeatable or not. If it is not, then definitely training score means it might be getting overfitted somewhere. So that's why we need to have it validated first on the validation data or test data. Only then we can be sure about our model.
Yeah, here the validation data is same as test data. We are not
Ah,
using.
yes, we are not using validation data specifically. Yeah, any other question?
Saurav,
Saurabh Chakravarti.
I wanted to ask regarding the balancing of data set. Suppose I have two classification levels, 0 and 1. And in 0 level, there are 344 points, and in 1, there are 120 points, just for example. So, when balancing it, will it leave the 0 level points, just randomly leave out the points in 0 level, or it also has algorithm inside it to make the points which are most biased towards the point to choose those points only?
I did not get it. I did not get your point exactly. Could you please repeat it?
Yeah. While balancing a data set of different labels, how is the balancing being done? Like just randomly leave out points from the one label, or
No, 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 no. So
suppose.
if you read about the balancing techniques, so basically there are like either you do, minority oversampling. So those data sets which are less in number, you can simply populate them. So that is minority oversampling, or the another one is majority downsampling. Okay, the name
Yeah,
itself is,
downsampling.
yeah, majority downsampling. But majority downsampling, you have the fear that you might be losing some important data, some vital data you
Exactly,
might be
exactly.
losing. Yeah,
Yeah.
so usually we do minority oversampling, the second one. However, in minority oversampling, if you read it on internet, you find that there are also some drawbacks to this particular thing. That's why there is one generalized model, SMOT, synthetic minority oversampling technique. So you can read about it. That will give you an idea how oversampling is happening. But many a time, like AWS classifier, on some data it gives results without even balancing. So that's why we have to, means we cannot say that balancing will always help on any model. That we cannot conclude. Okay.
Okay, okay. So there are different methods of balancing also.
yeah.
Oh, of course there are.
Okay, okay, fine, fine. This is what I wanted to know. Thank you very much.
Yeah, sure. Himanshu Sharma.
Yes, am I audible?
Yes, you are. Just a bit cluttering is there.
Okay. I just wanted to ask that could you please explain this random state parameter with a bit of an example? I'm not getting that particularly what it's used for.
So, Rishabh, you want to explain?
Yeah, so a random state is like we are splitting the data into 70 to 30 ratio randomly. Like we are taking randomly 70% of rows as in a test and 30% in train. Now to ensure that we just to ensure the reproducibility of the same splitting, we are using a seed value. So seed value is something like you can put it 1 2 3 or any number. It will just ensure that it will split the data again into the same random fashion. So for example, if the seed value is 1, suppose then it take a particular some 70% of row data and another 30%. And if you change the feed value, then it will change those 70% of data. Like it will not be the same one. And if the training and the test data are different, then it will lead to a change in our result. So just to compare the models, whether we are really improving or not, we fix the random state value.
Okay, so it's like it won't take that particular 70% every time. It will
Yeah,
randomly select 70 and
yeah.
30%.
So feed value just to ensure that it is choosing the same random point again and again.
Okay,
Compare the data.
okay, got it. Thank you.
Casina.
Yeah, Rishabh. So I'm just slightly confused between boosting and random forest. So in a random forest, do we do bootstrapping?
In random, yeah.
Okay, that's what I want.
So in every bagging process, we are doing bootstrapping, right? Okay, so now let's see the implementation of random forest. We have seen it earlier as well. Pratigya. Hmm. Pratigya, do you have any question?
Hello. Yeah. Can you hear me?
Yeah,
Yeah.
yeah, we are here hearing. Yeah.
So, can you just explain this that the estimators which you have put equal to 300, what are those?
Can you
The
repeat
number
again?
of estimate.
Estimators which you have put, n estimators,
Okay,
n
so it's
estimators.
basically the number of models to be used in this bagging classifier. So here we saw that
Acha.
that we are using multiple models, right? So here the n value is 300.
So just a copy of the base model. So our base model is in a decision tree. So it will simply create copy of that model up to 300. So you can also tweak this number. That is
Yeah.
again a
So
hyperparameter.
this is a hyperparameter, yeah.
Yes, and yeah. So people are asking, is random forest
Oh,
also a bagging
okay, sir.
classifier?
Yes.
It is, yeah. And seed argument can be of anything, any constant value. Yes, it can be. And what is oversampling exactly, can you elaborate? So yeah, so as we discussed, like oversampling means basically increasing the number of samples, as the name indicates. So like you are having class imbalance issue, so we are having zero of say 70%, one of only 30%. So in that case you can oversample this one thing so that it basically matches the number of samples with that of zero. Okay, so that is just the balancing, means balancing the number of samples in each class. Otherwise, the model might get biased towards one particular class. So that is our sampling.
Do we have more questions, Sudhakar?
So there is one question like why using bagging classifier and random first classifier if there is no difference between them? Why to
So
use it separately? Yeah.
yeah, right now I explained that random forest introduced some randomization, like we are sampling the features to be used for creating the trees in every model while training every model, and also we are subsampling the training data points for every bootstrap data set, right? So in random forest we are using the subsampling of these features to train every data set, to train for every decision tree model. Yeah. Harsh.
Hi, I have a question related to feature importance.
Okay.
Okay. So when I try to plot the feature importance by using random forest, I see a lot of features having some kind of importance. But the moment I change the classifier to XGB boost or something, it takes only few of those features. So my question is it general? So how to get the idea of a uniform feature over my whole model?
What do you mean by uniform feature?
Yeah.
Uniform feature importance. I mean, one classifier is giving importance to everything, another classifier is giving importance to only few of them.
Yeah, so that is bound to happen. I mean, depending on the
Yeah, yeah.
method of any classifier,
My
that is bound to
question is,
happen.
yeah. So my question is, if so, the moment I'm using XGB boost, the number of features are reduced. This will improve my model. So should I go for the reduced one or for the random forest one? So I just
Yeah,
want to
so
understand.
means it will again, yeah, we definitely got your point. So the point is that, I mean, we cannot be sure about one particular model, which means one model for all. We cannot say this thing because
Okay.
XGBoost definitely will help on some of the cases, and as it reduces the number of features, so you can
Mm-hmm.
see that it will reduce the model complexity, and it will also reduce the training time. So that
Mm-hmm.
is definitely a plus. But at the same time, there might be some training data set on some data set where means it might not work well. So that's why there is definitely a trade-off, or you might have to check on different models on your
Okay.
accuracy.
Okay. Okay. Thank you.
Yeah. Okay, so now let's start the implementation of random forest. Here we are importing this random forest regression model. These are again those same metrics, mean squared error, because we are using regression, and this is train test split the function. So we are using a data auto data. So this is how it looks like. So this is the training input for the model would be like our target variable is mpg. So y is mpg and remaining all are considered to be as input. Again, we will split it. We are not putting any stratify equals y type of parameter because we don't have any class in this model in this problem statement. So in random forest, since random forest is itself a model, so we don't need to pass the way we did for bagging classify, because it itself include all those bagging process and all those things. So it will take care of all those things, and we just need to pass the number of trees. Like there are hyperparameters for this, you can read in the documentation part. So I am just passing these three hyperparameters, and here I defined instantiate the random forest regressor RF. Then we fit on xtrain and ytrain, and then we can predict using RF dot predict xtest. And this is, since it's a regression model, we are using mean square error to get the sense of accuracy, and so accuracy here comes out to be 3.98. And using the feature importance function of a random forest, we can plot the importance of features. And we saw yesterday how it calculates the feature importance using OB dataset. And this is just for sorting to make it visually better. And we have used horizontal bar plots. So yeah, this is how we will plot. We can get an idea of the feature importance in case of random forest. Okay, so now we will look into the boosting part. Here again, we will use cancer data. We will use ADA boost classifier because target variable is a categorical 0 1, basically binary variable. And we need to define a decision tree classifier because ADA boost classifier is a technique where we have to pass the type of model that we are using. So here we will instantiate decision tree classifier dt with a maximum depth of 1. There can be other hyperparameter as well. And then base estimator equals dt, and number of estimator, that is number of models to construct, which will learn from the previous models on the basis of like as we saw yesterday. On it, they will learn from the error that is produced by the previous model. Then this we will fit this on xtrain and ytrain, like this is a training part. And then we can plot a ROC curve. This we have covered earlier as well. So we will plot the ROC curve, and more is the ROC area under curve value, better would be our prediction. And here it is coming 0.99. So yeah, it's predicting really good.
Yeah, so means on this particular data is that we can see that ADA Boost is really doing a very good job. So yeah, on breast cancer data set.
Okay, so I'm done with this notebook. If
Yeah,
anyone have question, please ask.
I think Yash had some. Yeah, Harsh, yeah,
Sorry,
Harsh. Yeah,
yeah,
please go
I
ahead.
forgot to lower my hand. Sorry.
Okay,
Okay.
fine. Ram Mohan.
Yes, so I wanted to ask, the ADA boosting technique seems like a general concept. Is it applicable only for like forest-based, like random forest or decision trees, or can we use it for mostly every machine learning algorithm?
So as far as I know, it's tree-based model. Yeah, in my opinion, it's only tree-based model. So you can only apply decision tree, random forest, these things.
The thing is, I'm confused because what we are basically doing is we are learning from the mistakes of the previous model, right?
Yes.
So we can generally do it for with, like, in theory, I think, at least in my mind.
Yeah, maybe you could have a look, but we think it's mainly used in tree-based models. Means as far as my knowledge is, means yeah. So I can only say this.
Yeah,
Maybe
we have always seen it to be used with using
yeah.
tree-based model.
Maybe you can find about it and let us know whether there are other techniques as well, which is means other models as well.
And it is different from random forest. Random forest using bagging technique. Here we are using boosting technique.
Yes.
Yeah,
The significant difference you can say that is bagging and boosting. The entirely two features we are using over here.
yeah, yeah. Thank you.
Yeah. Neeraj Kumar.
Sir, so here, as you have used the ADA boost, so you have created the ROC curve on the ADA boost, and we are seeing that ADA boost is doing good. But in the case of voting classifier, if we are using, and if we have used say, 3, 4 classifiers, in that case, how we are supposed to create this ROC curve, and how we will get to know that which one is performing better? I'm confused in that.
So, Mr. your point is that how to plot ROC curve in case of voting classifier, right?
Yeah, yeah, yeah.
Yeah, so that you can always do. Means in your case, voting classifier is the main model, and what is going inside that is black box. Means so you can take the means predictions of voting classifier like we did here. We are passing one argument, as you can see that model dot predict underscore proba. So you can simply do that there also. That model dot predict proba and your X test. So that way you can simply plot. Means if you want to plot each and every ROC, then you have to go like for each and every model you have to do this predict proba. But if you are
So
only
basically, you are telling that when in that case, when we are creating the ROC curve, we will not be aware that for which classifier we are creating. We will just know that okay, this is the one which ROC curve, which voting classifier is giving, right?
yeah, so means voting classifier is a majority based classifier. I mean, suppose there are five, so it will take which means which classifier voted for the majority one. So that is what we can say. Means again, and voting classifier is nothing but it's just an ensemble of the models which we have just defined. So it's a combined score of all of them, not an individual score, you can say.
Okay, yeah.
Yeah, and in order to compare, like we did, like we showed the individual scores first, and then we showed that 93% to 95% we could achieve. So that way you can also think about like whether ROC was improving from individual to an ensemble. That you can also try.
Okay, yeah. Thank you.
Yeah, thank you. Satyajit Das.
Yeah. Yeah. Hi, sir. So this random forest is actually taking the best of the decision tree, or it is doing the average of all the decision tree. I mean, is it internally implemented, or where we are doing the
So
decision
we
tree?
Yeah.
defined
So
method of
yeah.
estimators. Yeah, sir, please go ahead.
Yeah. So since it is a regressor, so it will average out the prediction from every
Yes.
model tree, and so it takes all those calculation. It will do on its own, and we don't have to explicitly mention that. So this function will take care of all those things.
So the best of the decision tree, right? I
No,
mean,
like as we saw here. In here, it will predict using every decision tree model and based on whether it's classification or regression problem. So for regression, it will just average out the all prediction value, and for classification, it will use majority voting.
oh, okay, okay, okay. Yeah, yeah, got it. Yeah, thank you.
Yeah, Shubham Singh.
Yes, sir. Am I audible?
Yeah.
Yeah, sure.
Yeah. So my question was on regression trees. So what we do in regression trees is that we first create a threshold and we start dividing the nodes to finally get some some leaves which have some numerical values. But regression trees are basically used to solve regression problems, right? So using this tree method, we actually get multiple categories. So isn't it converting the regression problem into more of a categorical one?
Hmm. Uh,
So like here basically a regression here doesn't mean exactly regression. It basically just imply that we are predicting a continuous variable.
But still, for example, let's say, for
Yeah,
example,
of
if I
course,
use,
when we are using a continuous variable for splitting a data, it is bifurcating them into two categories. One is lesser than a value x, another is lesser than value x.
yeah,
So
so for
in a
example,
way, it is converting that continuous value in two categories for in that but for particular node.
yeah, but still, if I use something like a polynomial function or something, so even if I fit a very large value which was not part of the data set, even though it's a outlier, but still it will give me a better output as compared to this regression tree, right? Because regression tree will only give me some fixed from some fixed categories that we built, right?
Sorry, can you repeat your question?
Let's say that I have a problem wherein I'm a regression problem. So I feed a very large value as an input. Let's say that there's one feature which is also numerical value, and it's giving it's a regression problem. So let's say that I feed a very large value. So I'll get a large value as an output as well, which is actually trained using the polynomial function. But for regression trees, it has some fixed categories wherein it ends in the leaf, so it wouldn't give me that large value which was expected.
No, for the since decision trees are they are famous for overfitting. So if you have a very like these kind of outliers, then they will catch them first, and they will make a separate node for that.
Okay. And there was one more question in just in this ADA boost. There was this parameter uh, base estimator. So I think it's possible that we could feed any other classifier as well, like logistic regression or something.
Well,
So
in these all boosting technique, what I am aware of, we will always use a decision tree model for every predictors.
what is that parameter used for base estimator?
Base estimator. What do you mean by base
Uh,
estimator?
Yeah.
in the notebook there you have implemented ADA boost. There is an estimator that you have used, base estimator. It is equal to
Okay, so
DP.
base estimator is your base model.
Yeah,
Uh,
so I could change the base model to a logistic regression, right? So it will boost the logistic regression one. It's simply we are waiting.
Ideally it should. However, I have not tried it. You can explore that part actually.
Okay. Fine. Thanks.
Yeah.
Yeah. Kasina. Yes. Kasina.
Yes, sir. So I was wondering what the voting classifier does. Is it that because in the voting classifier code you've written estimators equal to classifiers, right? So is it that it is going to take the for each new data point we give, it is going to take an average of the logistic regression, KNN, and classification tree, and then decide what is the output? Is it like that?
So see, it is a classifier. Like so, means suppose there are five classifiers, and they predicted like 1 1 0 0 means the three ones and
Hmm.
two zeros. Okay.
Hmm.
So it will simply give that this row should be labeled as one. So that is
Yeah,
simply a
that's
voting. Yeah.
so meaning it is using three other models, and then amongst them it is voting, right?
Yeah.
Yes.
Here we are
Amongst
not
them, they.
bound to use tree models only.
Yeah,
Yes.
meaning excuse me.
Here we are not bounded to use only tree models. We can use any model.
Yeah,
Okay.
we have also used Canon. As you can see that we have used Canon in this model.
Yes,
CNN,
yes.
logistic regression, anyway.
Yes, all these things. So here we're not bound to any tree based. We can do anything. We can do
Anything
anything.
that can be used as a classifier model.
Yes.
Can we use a random forest?
I think we have done that. No,
You
yeah,
haven't. You've
definitely you
used
can do
legis.
that.
Yeah, you
Yeah,
can
you
use
can do
I
that.
guess.
You can
Yeah,
do
yeah.
that.
Okay. Sure. Thanks.
Yes, Sanjeev.
So I wanted to speak a little about the previous doubts of everyone and a doubt that I have. So
Yes, sure.
we can use the base estimator as a logistic regression in ADA boost classifier. Okay. It does give us a result, but for me it didn't do good. It actually did worse than a single logistic regression classifier. And also it cannot be used with everything. It could not be used with neural networks. It only works with base estimators which have a parameter called sample weight. Otherwise it gives an error. The boosting happens with sample weight being randomly chosen with the help of a seed that is provided. So we can't use everything, but logistic regression can be used in AdaBoost classifier. However, it did not work well. That was the first thing. Secondly, regarding that random forest regressor. So what as far as I read about that, it seems like it tries to give some data points to a node such that their mean is not too varied, as in the x test that we studied about, the t test, the p value should be greater than 0.05 or something for them to be there in a single node. So it does seem like they clump out and then they take the mean to be the value of that regressor. Okay, so to be the value of that node. So it does seem like it takes all the training points and then clumps them together, whichever seem to be close. And then if I put in an outlier point, then it might throw it in the most extreme training set which was found, but that still might not be enough to give us a good value. As in, if the classifier is x is equal to y, let's say, and the training set is in the range of 0 to 20, and I provide something on the range of 200, would the random regressor forest regressor work?
Yeah, means I think you talk about a lot of things, so we missed your question actually. Just you
Okay,
can.
okay. Yeah, yeah. So what I initially said was ki for AdaBoost classifier, we can use the logistic regression model as a base estimator. However, it did not do good, at least for me in the assignment when I tried it. And it does not work for everything. The base estimator cannot be a neural network at the very
Yeah,
least.
so let me stop you here. So that's why means we have not explored ADA boost on other classifier. We have just tried it on tree-based models. Okay.
Yes, on the
So we are
tree-based
also
models, it does good. It does better than what the original one tree could have done. But
yes.
on
So
logistic regression,
yes.
it does bad.
Okay, so we are
So
not. Yeah, that's why we also need to check. Means we did not try it on non-tree based models.
yes,
Okay, so you can
and
explore it. Yeah.
yeah, the next thing I wanted to talk about was the random forest regressor. For example, a tree-based regressor, anything. So as far as I read about it, it seemed like it goes on. If you set a if you there's a parameter which you set, which basically decides on how close the values need to be so that they are put in one node and node is not split again. So to decide that value, what they do is they do a t-test to find out whether they belong to a distribution with the same mean, and they decide the p value to be 0. The alpha to be 0.05 or something for them to be clumped together, and that's how they make the regressor, because there are a finite number of leaves that you're going to have in the regressor. So it seems as if there can only be a finite number of values which can be provided to a new test data that is given. So if that test data is extremely towards, I mean, it's a huge outlier to one side, then it does not seem like the regressor uh, should give a good estimate, but it does actually. I mean, it didn't do bad over here when I tried it. Why is that?
Yeah, we are. Means I am not sure at least about it. Means you will definitely read about it more,
Yes,
and then you
thank
will
you.
post them. Means I am not basically sure about it.
Yes.
Yeah, we will
So
post something on campus regarding this question.
so
And
since the question is very long, should I also put it on the campus wire?
Yeah, yeah, sure.
yes, that will
Thank you.
definitely very helpful. And one
Thank you.
more thing, like I hope that you guys have seen the assignment. We have released it. I think today afternoon only, means 5 p.m. or something. So I
Yes,
hope
yes.
that you guys have gone through means this assignment, and yeah, so you're working on it as well. So if you have any doubt in the data set which we have given in that assignment, we can discuss that here also, because tomorrow onwards we are moving on another topics. So here we can discuss about that data set as well, that assignment thing.
Yeah, so we will switch to this part.
Yeah, if anyone has any doubt, we will be happy to discuss that as well. So there is one
So
question that decision tree is not affected by outlier. No, it is. Decision tree are means they are affected by outliers, because they are means they basically create the regions. So they will be affected by outliers for sure. And random forest, since it means it takes an collection of number of estimators, so it might reduce that variance. It will not affect much, but decision tree for sure will get affected. Yeah, and yeah, please go ahead. I think that someone was saying anything. Yes, yeah, you were saying something.
Yeah, I wanted to ask a question. So I was trying to fill the NaN values in the data that you provided, the Titanic data for the assignment,
In which column?
for age and embarked.
Okay.
Okay.
So for age, I mean, I put in value is equal to Titanic data age dot mean and in place true, so it worked. But with embarked, when I put in mode, it did not work. It still showed embarked had two NaN values as before.
So
But
you are
then
doing, yeah, yeah, please go ahead.
but then what I did was plotted out its histogram, and I saw that S was the mode. Clearly S was the mode. So I put in value equal to S, and then it worked. So
So
why
I
was
think you are not calling mode properly. Are you using parenthesis after mode?
yes, same as mean.
But
Okay.
we need to ensure whether that function exists or not. It is not a by
Mode
default.
exists. Mode exists because I have also worked on that data set. So means mode
So
works.
I can rather put this as a screenshot on campus Era, right?
Yes, yes,
That would work.
yes. One hint or which I would like to add here is that means while replacing the NaN values, you can also think about that whether that column is having how much number of missing values, only one, two, three. Means if that number is not very high, suppose like in case of age you are having some 100 plus data, I think more than that data were missing. But in case of embarked, we are having only two missing points. So in that case, you can also try about dropping those rows only, since there are only two missing points. Are you getting my point?
Yes, yes. Thank you.
And you have something called drop in a subset equal to.
Yes, yes. Drop
So
in it.
that you
Yes.
can try, and that will help if the data points are not missing largely, not significantly. Then that will help.
Thank you.
Yeah. Anyone else regarding assignment thing? We can discuss about it more. Yes, are you done? Yes, are
Yes,
you done?
yes, yes,
Yes.
yes. Thank you.
Okay,
Thank you.
sure. Anyone else? Any chat or something? Let me check. Okay. I have a generic question. Joydeep Ghat. Yeah, Joydeep, could you please speak or let us know? Okay, when we are doing one hot encoding using get dummies, we are getting lots of extra columns along with the original columns. Yeah. So do we? Okay. So do we have to remove the original columns, or we can take all the columns together and put? Okay. So see, Jaideep, the point is that in case of get dummies, you have one argument. Sorry, we have one argument that is drop underscore first equal to true. You can read about it. That is called dummy trap. So basically, if you are having one column, suppose sex, that is male female. So if you do this get dummy, you will get sex male one column, sex female second column. After you apply drop first, one column will be dropped, means you will be having only sex male or only sex female. So and it will put 0 1 in that column. So by doing that, you can reduce one column in appearing extra. Okay, that you can definitely do, and that will help while training as well. And yeah, so if you keep all the columns together, so definitely like you will have to keep all the columns if the columns are having vital information. Like in titering dataset, you are having one column called embarked, and those I think are having three distinct values, S, G, or something. So you have to keep all, you have to keep them. But while splitting, you can drop one, you can have only two. So instead of three, you will be having two columns, but you have to keep all the columns. Okay. Original columns are dropped automatically. Original columns, the moment you do this get dummies, na, original columns will be dropped automatically.
I don't think so. The original columns are not dropped. I mean I tried it. The original you store them in a new data frame and
No,
even
no. I guess if you are applying pd dot get underscore dummies of df, the original columns are dropped. I guess I've
oh,
like
Yes, they
Uh,
are dropped. Yeah.
actually, I have seen. Actually, I have seen that original columns stays as it is. For example, if it is a gender or sex, So it changes from a male female to 0 1, but you get, as you have said, you have got a male column separately, you got a female column separately, where it is either 0 or 1. So original column also stays.
Okay, so we can just drop them out. Or
Yeah, if
So
it is, but I think it should not happen because I also tried.
Hey, it is there. I just tried it. I just tried it. It's there.
it
Did
is
you
there.
try for the
It changes from categorical to 0 and 1. I mean, it changes to numeric, but it creates another 2 column like male and
Yes, yes, yes. The original is also there and the new is also there. After
right.
one hot encoding is also there.
Right. So my question is basically, for example, when for a particular data frame is equal to pd dot df is equal to pd dot get dummies then df. So we are creating a new data frame which has some more columns. But if we try to use shape, it will show the same number of columns on the previous and the new data frame, even if the number of columns is increased. So my question is, are we going to manually delete the new columns on that new data frame, the old columns, or we'll just keep as it is?
how can it show the same number of data columns?
Yeah,
Like,
that is the
different.
question. So I'll try again. So but
Yeah,
yesterday
in
I
my
tried.
opinion, it has to, first of all, it has to be different, and this those columns that have string value you can drop manually if you can't find any other way.
Right. I mean, if we can do one-hot encoding on this one directly on Titanic, we can see right away. So my question is, do we have to keep the original column along with the new columns, or we have
No,
to
we can't keep, because these value have string values. We can't pass string value to a model while training.
True, that is true. That is true. But when you get dummies, so it changes also that particular column.
What
So
will it change to?
just a new, yeah. So we can try that one.
Okay, fine.
It seems the number of columns change. I mean,
it was showing more.
yes, it was showing more. It
Yeah,
was
it
showing
has
11,
to be,
and it showed
because
9.
Okay.
You check once.
I'll try it again, because
Yeah.
when I tried, maybe there's some cache was there, so that's why I was not that confident on that. But I'll try it again. Yeah.
Sir, I had a question. Small question. It's more of an afterthought. You said that I should drop the 2 rows since I had only 2 nan values. I did that, and the accuracy jumped by 5%. Why? I mean, why is that? With just 2 values removed, the accuracy jumped from 80 to 85%.
Yeah, I mean, I also cannot comment on this because I'm not sure. The thing is, chances are high that those 2 rows were some outliers. Means the other columns, the other values of other columns, there might be this case as well. Like suppose age or suppose sib sp parts, these things were having something values which were creating disturbances to the actual model. So that's why that's why we have been emphasizing on this thing, that you since know all the tools, means the tools which you have covered so far, so just implement all of them one by one and you will definitely get a hang of it, like when to use which tool with which data. Definitely you will get a hang. And
So
yeah,
using a
that will
box plot should have been good, right? I should have used a box plot to check out for outliers.
definitely means outlier thing I just spoke out of my mind. I am not sure about it. I am just giving you one angle which might have which might have been dropping the accuracy. It might be, there might be
Thank
some
you.
other
Thank
reason
you.
as well. Yeah.
Yes. Thank you very much.
Welcome. Yeah, any other question? Anyone? Chat is clear. So I think if we are not having any question, then
Yeah, we can
sir
stop here.
sir is here, Amit sir.
Yeah, I'm here.
Yes sir, so yes sir, so should we call it a day? I think
Yeah, we
there are
can. So you covered the main
yes sir,
purpose of
I
the
can
assignment
see.
also, right?
Yes sir, I think, yes sir, we have done that. Yes sir, I think Ram Mohan has some point. Ram Mohan, yeah,
Yeah,
you can.
yes, sir. Actually, I wanted to ask some questions from the yesterday's lecture.
Yesterday's lecture notebook.
Yeah, notes,
Okay.
slide notes,
Sli- Slides or the Google Colab notebook?
slides. Yeah.
Slides, research slides. Yeah.
Okay, please ask.
Yeah. So one thing that sir told was if we have, so I'm talking about the normal decision tree here,
Okay.
the first one. So what sir told was if we have d variables and n training points,
Yeah.
so then we have to do d into n minus 1 test for each threshold. So basically for
No,
every
not for each.
variable,
Sorry, not for each. Only for the root.
yes, sir. So not for each, only for the root.
Yes, because after that, you will split n into two subsets. One that will go to the left child,
Yes,
and
yes, sir.
the
Yes,
other
sir.
that will go to the
Yes,
right
sir.
child. So let's
Yes,
say
sir.
that is m and p. So now you will do m minus one times d, and then p minus one times d on the right side.
Yes, sir. So I meant for the root node, for every variable we have to do n minus one test.
Yes.
So then we discussed that what if the point is in between. So what I actually and then you said it does not matter if the threshold is closer to 1 point or farther away from 1 point.
Yeah, but it's customary to actually just take midway between 2 points.
So I was confused about this point, sir. Like I did not understand it yesterday, but right now I understand my confusion. Like let's say that two thresholds are 5 and 6. Then there can be infinitely many number of points in between these two. So
Right.
how do
So,
we?
so if you want, there's something called structural risk. If you want to minimize the structural risk, you will try to maximize the margin between the 2 points. So you will take the midway.
So the median or the
No,
mean?
no, not the median. These points are rank ordered, right?
Yes, sir.
They are sorted. So you take any 2 points. Between them, there is a bisector, right?
Yes, sir.
There are n minus one bisectors between n points, between the first 2 points, second point and the third point and the fourth point, etc., etc.
So sir, if we consider that because these points can be multidimensional, so every dimension of these points would
No,
have.
no, we are talking about only one dimension at a time. That's why I said
Okay, sir.
for each variable you are looking at n minus one thresholds. Okay, we'll look at it only one dimension at a time.
Yes, sir. Yes, sir. Also, sir, can we walk through the algorithm of like basic algorithm? By basic algorithm, I mean like let's say we are given a few sets of data set of points. Then if I were to like start coding forest this decision tree,
Yeah.
first I would split them into training, validation, everything. Then when I come to the data structure, now I first need to find the node, the first root node. That I can see that I can find it through the information gain thing,
Yeah.
feature and the feature and then the threshold value.
Yeah.
Then how do I proceed?
So let's say you have 5 variables and you have 100 data points.
Yes, sir.
So you will do 5 times 99 tests, out
Yes.
of which whichever test gives you the maximum information gain, you
Yes.
will put that test in the root node.
Yes, sir.
Now it has split the 100 data points into, let's say, 30 and 70. 30 go to the left child, 70 go to the right child.
Yes, sir.
So for the left child, now you will do 5 times 29 tests. For the right child, you will do 5 times 69 tests. Okay.
Yes, sir. So we are trying to figure out the height of the tree and the nodes at the
Right.
time of data.
So if you split, if your root node splits it in such a way that this 30 and 70 are such that all 30 are from class 1 and all 70 are from class 2,
Yes, sir.
then you don't, those are the leaf nodes. You don't need to split those left child and right child further anymore.
So I would have these termination conditions
Yeah,
for.
and you will also have this termination condition. If for some reason these are not completely pure, and then you have some criteria that they have to meet a certain threshold of purity, and they haven't met that, they are still a mixture of class 1 and class 2 in those 30 samples that came to left child,
Yes, sir.
and class 1 and class 2 are also mixed in the 70 samples that went to the right child. Then you would repeat the process for the 30 samples on the left node. left child node and have its own children, which is the grandchildren of the root node.
Yes, sir.
And then you'll do the same thing on the right child and have grandchildren of the root node.
Yes, sir.
Okay. Yeah. Clear?
Yes, sir. Yes, sir.
Okay. All right. So I guess we can call it a day then.
Yeah. Thank you.
All right. Thank you.